So we're just beginning Module 8 in the OLI textbook, and this is the beginning of their sequence about probability. Now, today's presentation is from the workbook. It's a topic on counting. It's not covered in any depth in the OLI textbook, but if you know something about counting, it makes the discussion of probability easier to understand. And so I've added this topic at the beginning of Module 8. It's one section, Topic 1, in Module 8 in the workbook. But even though it's only one topic in the workbook summarizes it in about 2 pages. There's actually a lot more to it. And so I'm going to do the video lectures in several parts. I'm going to do this one today just on some background ideas about counting. And then we'll have about 3 or 4 more short videos after that, all connected with this Topic 1 to get you ready for Module 8. Now, what do I mean when I say talk about counting? I know we learned how to count when we were really young. Okay. But that's not what this is. These are questions like, how many ways could you possibly choose a sample of 100 individuals to be selected from a population of 10,000? You can't list all those different sets of 100 people. There are just too many ways that you could pick the people in the sample. But we'll have formulas that will allow us to calculate such things. Another one, how many ways could you arrange 3 objects? Or 10 objects, however many. How many different sets of 3-letter words are possible in a 26-letter alphabet? How many different ways could a poker hand be what you call a full house, where you have 2 of one kind and 3 of another kind? So all of these share a characteristic that there are formulas that can make it easy to figure out the number, but to do it by listing, pointing the way you counted things when you were young would really not be feasible. Now, we have some tools that we can use to address these questions. And we're going to start with really simple, sort of everyday background ideas. When I write these things down, you're going to say, this is really simple and obvious. And then we want to take those simple ideas and put them together to make some formulas, 4 different formulas that cover a huge variety of different counting problems. And it's something that I like about math, and it comes up not just in probability, not just with counting, but so often it's a matter of taking really simple ideas and just putting them together in a different way, and then you get something that you never would have thought of, maybe. And then when you see it, you realize it's got to be true, and it covers a wide range of problems. I just like it when that happens. Okay. So these three background ideas that I'm talking about for today, for this particular lecture, are the multiplication principle, tree diagrams, and factorial notation. That's as far as I'll get in this video. In a later video, we'll use these to make our four counting formulas. And then the challenge for the homework is, the first homework is learning to match up, okay, which formula goes with which word problem. Okay. Now the learning objectives described for topic 1 in the workbook go beyond what we're doing in this one lecture. Yes, we're going to understand the three background ideas, but then these other items, I'll break them off into separate lectures. So here are these background ideas. And you'll like this part. It's easy. Suppose you've got, and I'm not just going to go through the workbook in these talks. I'm going to be guided by the workbook, but I need to draw you some pictures as well. And so that's why there's a video in addition to the workbook. Suppose there are three choices for the flavor of ice cream, and two choices for the sprinkles that you could put on top. How many ways can you choose a flavor and a sprinkle? There's 6 ways. I'm going to draw a picture. You need to have in your mind some pictures that you can draw to help you solve the word problems later. So here are my 3 flavors. I've got chocolate, I've got strawberry, and I've got vanilla. And then for my sprinkles, let's say I could put nuts. Or I could put candies. So you see there's 6 different places. I want the chocolate and the nuts. There's 6 different places where you could put your check mark. 2 rows of 3, so you multiply 2 times 3, you get 6. So if you have to make 2 decisions in a row, you're going to make a decision among n alternatives, like 3, n could be 3 flavors, m could be 2 sprinkles. You're making 2 decisions in a row. You just multiply the number of alternatives available at each step. Okay. Oh, and what if you also got to choose a you can choose a topping. You can get whipped cream. Or if you don't want the whipped cream, you could have chocolate syrup. Oh no, why couldn't you just have both? Well, make a good problem. You got to choose one or the other. So now for all 3 decisions together, Well, you decide which way to, where to put your check mark up here, and then you've got another decision. So instead of having 6 different ways you could go, you've got 12 different ways you could go. So in the workbook, I just mentioned for 2 decisions you multiply, but if it was 3 decisions, you'd still multiply. I mean, the way you think about that is, even though it's 3 decisions, you can still treat it like 2. There's the combined decision for the ice cream and the topping. That was 1 decision, and then you multiply by however many there are at the next step. So it's still just, you can think of it like 2 decisions. And then you take the first decision and you break it down into steps. Okay. So however many decisions, you can multiply. But that doesn't always solve all of your counting problems. If it was that simple, we wouldn't have four lectures on it, right? Okay, so the next step up, tree diagrams. Oh, I put the heading on here. This one was multiplication principle. And then the next one is tree diagrams. Okay, so this time you can choose, you're gonna buy a truck. You can either get a Ford or a Chevy truck. Okay. Well, the Ford's got 3 colors. And the Chevy's got 2 colors. So, how many different trucks could you pick? There's 5. A red Ford, a blue Ford, a green Ford, a black Chevy, or a white Chevy. Now, why is this different from the problem before? So with the multiplication principle, the number of alternatives at each step does not depend on the choice that you made at the previous step. I'll call that independent choices. The number of, you've got 2 different kinds of sprinkle, regardless which flavor you picked. But that doesn't work if the number of alternatives depends on what you chose at the previous step. And so then one solution is to make a tree diagram. And I got one more of these background ideas, and it's just going to be a matter of putting these 3 things together in sort of fancy ways to make our 4 counting formulas that really cover a lot of ground. Okay. So, just for your notes, if you're going to scribble down some notes, the number of alternatives depends on previous choices. I mean, the diagram works. Diagrams would work for the independent choices as well. Covers more ground. Okay. Now, let's see, factorial notation. So, The question here is, how many ways can you arrange 5 objects? Well, there's 5 objects, and there are a lot of different ways that you could arrange them. I mean, you got to decide who's going to come first. I put a green one first, but there were 5 ways I could have gone on who comes first. So let's use a tree diagram. So there's the 5 different ways I could have gone on who comes first. Now, how many ways could I go on who comes second? Well, I already used the green one here, so I just have to use one of the other 4 colors. And I could do the same thing on down with those others, be different colors. But I've come to 5 times 4, I've come to 20 different ways that I could get to the point where I have chosen 2 colors. And then you go from there. There's going to be 3 ways. And then 2, and then 1. See, so for every one of these 20 ways I could have gotten the first, for every one of the 20 ways I could have gotten to the first 2 decisions, there were 3 ways to get to the 3rd decision. So we're up to 60 different choices after 3 decisions. And then there's 2 ways to go on each of those. And after that, there's only 1 way. Okay, so what's the formula? There were 5 alternatives for the first decision by the multiplication principle. You multiply times the number of choices at the second decision. There were 4, so we're up to 20. And so it goes. The number of ways to arrange 5 things: 5 times 4 times 3 times 2 times 1. And if you're going to arrange n objects, you do n times n minus 1 times n minus 2, all the way down to 1. There's a quick notation for that. Put the little exclamation point after it. It means do this. You pronounce that n factorial. Okay. So that's all for this video. And in the next video, we'll try to put these simple ideas, multiplication principle, tree diagram, factorial notation, into some fancier formulas. So I'll see you in the next video.